Well, good morning, everyone. My name is Timothy Lee Grant, and today we are going to be talking about the arrow operator. And so, when I first encountered the arrow operator, I didn't really know when to use the arrow operator and when to use the dot operator. I kind of just haphazardly used one or the other, and then if I got an error, I would just switch on over. So, that was my main method, but not very good because I didn't have a good understanding of what it was actually doing and when to use one versus the other. And it really showed that I had a fundamental gap in my knowledge of programming. So today, hopefully, we will be able to fill in that gap and get you guys to understand the difference between the arrow operator and the dot operator, when to use one, when to use the other, because they're actually doing two different things. Okay, so let's start with the arrow operator. The arrow operator, if I do something like this right here, okay? So it's a big, long sentence, and we're going to get through it. All right, so I am declaring a pointer variable, okay? So when I was talking about pointers, whenever you see a declaration, okay, and you see this little star, hold up. We have a special variable on our hands. It is a pointer variable. Okay, so bam, we know that it's a pointer, and what does it point to? It points to a struct animal, okay? So we know that we are going to be having a pointer, okay? And that pointer is going to hold the memory address that a struct lives in, okay? So this struct gets memory, and it's at 1000, right? So the computer just decided to put this struct, this block of memory, at 1000, and then that memory is where the struct is going to live, and we declared a pointer that inside this pointer is going to live the memory address where the struct is, okay? So that's what P is. That's the pointer variable. Inside of P is the address which the struct lives at, all right? So now this malloc right here, okay, what this malloc function does is it tells the compiler, okay, I want you to go and find a certain amount of memory. Once you find this memory, I want you to allocate it. I want you to save this memory because I'm going to be using it. Okay, so block off this memory, and how much memory do you want? Well, that's how you have to tell it. So that's what this size of does. Okay, so the size of, it takes in an argument, which we put the struct animal right here. That's the argument. So size of takes in an argument, and it returns how much memory that argument that you put in is. So I said, okay, well, struct animal is what I want to determine how big it is. I want to know how much memory this struct called animal, this struct animal, I want to know how big that struct actually is. How much memory does it take up? So I put it through the size of call, right? And this is going to take in the argument, and it's going to return the size, how much memory this struct needs. And so this is going to evaluate to some number, and the number of bytes that this struct animal has. Maybe like 250, right? Some number. And then that is going to be passed into this malloc. And the malloc says, okay, well, I see that I need 250 bytes. I'm going to allocate it somewhere in heap, okay? And then I'm going to return the address of where I allocated that memory. So this says, okay, great, I allocated the memory. Now I'm going to return the address, which, remember, that's the entire idea of a pointer value, right? Is it stores the address of a struct or of any type of variable, but in this case it's a struct, right? because we declared it a struct. Like that, you normally have like int star. Okay, well that holds the address of where an int is. But in this case, it's what lives at the address is a struct animal. Okay, so it returns this malloc function, allocates the memory, and then says, okay, once I allocated it, my output, my return value, is going to be the address which I allocated this block of memory to be. But then, okay, if we didn't have this right here, we wouldn't really know what this p-value is, right? Because, okay, I allocated the memory, but it's not necessarily, that's just 250 bytes. Like it just allocated 250 bytes and I returned where that 250 bytes is. But it's not actually isn't it int? Is it just a whole bunch of integer values? Is it, like, what is this, right? The compiler is going to get confused. What is this? You just allocated 250 bytes, but I don't know what's actually there. Well, you have to cast it, okay? So this says, all right, well, this 250 bytes, this 250 bytes that you just allocated, and you returned the address which those 250 bytes lives at. This is going to be a struct animal pointer. Okay, so you cast it as a struct animal pointer and save it into P. All right, so now we know that this memory location, which is sent to, or which is given by the malloc function, is a struct animal pointer, so that way it can save into P. Great. Cool, we allocated P. Huge long statement. But now let's actually get something going with P. Okay, so let's access one of its member variables. And let's say that this struct animal has a member variable called age, right? If it's an animal, it has an age. Okay, cool. So can I just go P dot age equals 10? Can I do that? Well, no, I can't. I can't do that because this P is not a struct. Does that make sense? This P right here, see? This just holds an address. It's not a struct. See? So you can't find the age member variable on just an address. That doesn't make sense. So what do you have to do? Well, what you have to do is you first have to take P, okay, and then you dereference it, and then you can find the member variable. So let's kind of go through what's going on, right? So I have P. It's right there. Okay. This dereference operator says go to the address which is stored in this pointer value. Okay, so I go to P. Here's the address which is stored in the pointer variable. I go to it and get this struct. Now I have the struct. I no longer have the pointer. I have the struct. Okay? Now I have the struct, and from the struct I can access the member variable and change it to 10. So, this notation is a little bit cumbersome, right? Because you have to, there's multiple things going on. And that's where the arrow operator actually comes into play. Okay? So instead of this, I can actually just go P arrow age equals 10. And that's what the arrow operator actually is for. That these two statements are identical. The arrow operator just means do two things at the same time. Number one, take this argument right here and dereference it, okay? And then get the member variable right here, and then you can access it, right? So dereference this pointer, get the member variable, and then you can do something, right? That's what this arrow operator actually means. It just means dereference this argument and then get the member of this argument. Does that make sense? So the arrow operator is for pointers. Arrow operator, this is going to be a pointer, okay? And then this is the member variable. So if you don't have a pointer, you can't do this. If, for example, we have in our code something like struct animal, I should have given myself more space, all right. Struct animal. Okay, so here's would be just like int, right? This is just the type. This is just a type right here. Struct animal is just a type. Okay, struct animal, and then what's a cat name? I can't think. Bella. Okay, struct animal, that's like int. Int, here's the declaration, here's and then struct, and then you can say like my var, right? Here's the declaration right here, right there, and then here is the name right there. So struct animal Bella. Okay, so we created this variable, which is of type struct animal. Okay, now, if I want to access the age member variable of this struct animal, Bella, now, am I going to use the arrow operator? No, because Bella is not a pointer. Here is a pointer. This holds an address of what? Of a struct. So it does not hold the struct, it holds the address of the struct. This is the actual struct. So in our code, if we declare Bella like this, we can actually go Bella dot age equals 20. Okay? We cannot go Bella like this, age equals 20. No, because what this would mean is we are taking, I'll write it down. What this would mean is we are going Bella, and then we're going to dereference it, okay? Then dot age equals 20. And this doesn't make sense, right? Because Bella, how do you dereference Bella? That doesn't make sense. So you don't use the arrow operator. Arrow operator is for pointers. These two statements are identical, okay? And this is something that maybe try writing out multiple times, okay? It might be kind of annoying, right? But that's how you're going to learn, is try, instead of writing this, write this, and then in the comments right next to it, write out the full thing. Write out this dereference operator, dot age, right? Do that a few times, and pretty soon you'll start to recognize, okay, well, I understand what the arrow is doing. It's just taking this pointer value, dereferencing it, and then accessing this member variable. Okay? If you have the actual struct, not a pointer, an actual struct, then you can just access the member variable of that struct, because that makes sense. Bella is a struct animal, And in this struct, there is a member variable called age, and you set it to 20, no problem. But a pointer is a address. It's an address. It doesn't have a member variable. What it's pointing to has a member variable, right? It's pointing to here, and this has a member variable. This has an age, okay? But first, before you actually can access this age, you need to go to the memory address, which it lives at this pointer, okay? Age, and then you can set it. And that's what this arrow does. Okay, and I guess I mentioned this in my last video, but I just wanted to go or say this again because it confused me when I was first learning about pointers. This arrow, or this star right here, and this star right here, they don't have the same meaning, okay? This one right here just means it's in a declaration. So we are declaring a variable. And so when you see a star in a declaration, you say, hold up, this is a pointer. Okay, that's what this star means in this context. This star means something different. What this star means is take this argument right here, this P, and dereference it. So P is a pointer, and it stores a memory address. What this star is telling you is go to the place where this memory address is. Okay, so those are two different things. If it's in a declaration, it means it's just a special kind of variable called a pointer. If it's in this context, it's a dereference operator, and it gets what's at the memory address. Okay, two different things. All right, so here is the main difference between the arrow operator and the dot operator and how you use them differently. And so this is also like why you would want to use them is because when you want to dynamically allocate memory, because for example, if you don't know how much memory you actually want to allocate when you're programming it, that's kind of up to the user when they're doing their stuff, right? You're going to want to be able to dynamically allocate memory as the program goes on. Well, in order to do that, you have to use the pointers to access the memory which is allocated on the heap, okay? So that's why you would want to do it. Another reason is if you want to pass in a struct to a function, a lot of times people use a pointer variable to access the struct. So there's a lot of usages, but this is the difference between the arrow and the dot operator. So thank you guys so much for watching this video. I hope that it is more clear. If you'd be so kind as to actually give me a comment and let me know how I did, that would be extremely appreciative. I want to continue to make my videos better and better and make them more informative, more clear, so I would greatly appreciate any feedback which you could give me, and I hope that I was able to clear up some of these conceptions and concepts, because I know when I was learning to program, these things aren't hard. Insofar as once it's explained, you're like, oh, okay. But there's so many of these little gaps in your knowledge that if you don't fully understand it, you might think you know it, but because you don't actually know it, it just gets really convoluted, and you're just so confused. So that's kind of why I want to make these videos, is kind of figure out those things which really threw me, that caused me to just be in a muck almost. And I want to be able to actually go through them and try to explain okay, well, what's actually going on? What's happening with this? What's the difference between this and the other thing, right? For example, this asterisk really threw me off because I didn't recognize that those had two different separate meanings, right? I thought that they were the same thing. And so even though that's such a little concept, it really made me confused. And actually, when I first when I first started programming, I didn't like pointers at all because I was so confused by them. I didn't know what was going on. And then this was another thing. I was like, well, when do I use this? When do I use that? And I just got this bad taste in my mouth that I was very uh, hesitant to use pointers. So hopefully I am able to clear up some of those and get you guys on a good foot. That way you're able to move forward confidently, right? So please let me know how it is or how my videos are. If you have any questions, if I didn't explain something clear, or if you're encountering something else in your programming career and you're like, I don't understand something. I can't find a clear video online. Could you explain something? Just hit me up, let me know, and I would really like to hear you guys' feedback. Anyways, have a wonderful day, and I will see you later.